What is electromagnetic induction? In the year following the discovery by Oersted that an electric current produces a magnetic field of induction, the question before the scientists was whether a magnetic field can in some way induce an electric current electric current. Continuous attempts were made for about 10 years to detect currents in the coils by subjecting them to strong magnetic fields, but the answer was that such an effect apparently does not exist. 1830, Joseph Hadley in the United States and a year later Faraday in England independently observed that an EMF is set up in a coil placed in a magnetic field whenever the flux through the coils changes. The effect is called electromagnetic induction, and if the coil forms a part of a closed circuit, the induced EMF causes a current to flow in the circuit. Experiments show the magnitude of EMF depends on the rate at which the flux through the coil changes. It also depends on the number of turns n on the coil, and it is useful to define a quantity called flux linkage as being the product of the number of turns and the flux through the coil. Flux linkage is equal to n. It is not necessary that the conductor is in the form of a coil in order for it to be able to acquire an EMF. EMF can be induced in a straight conductor whenever it is caused to cut across magnetic induction lines. The magnetic flux through a circuit can be changed in a number of different ways by changing the relative position of the coil with respect to a magnet or current bearing solenoid, by changing the current in the neighboring coil, or by changing current in the coil itself. It should be noted that early attempts were bound to fail because the coil has resistance and energy is necessary to force current through it. No energy is expended when the coil is lying motionless in the field. Laws of electromagnetic induction. A detailed investigation of magnetic field of induction leads to two laws known as Faraday's laws. An EMF is induced in a coil through which the magnetic flux is changing. The EMF lasts so long as the change of flux is in progress and becomes zero as soon as the flux through the coil becomes constant. The magnitude of induced EMF depends only upon the number of turns and the time rate of change of flux linked with the circuit. It can be expressed as this equation. The negative sign is introduced for the reason to be explained in the next article, which is Lenz's law and self-induction mutual induction, and non-inductive winding.